Hey everybody, this is Larry. This is me with Q3 of the weekly contest 467, Subsequence sum after capping elements. Hit the like button, subscribe button, join me in Discord, let me know what you think about this one. There's apparently a lot of optimizations that you can do with this one. I'm not going to go over any of them. I would say I'm not a fan of this problem in general. I end up taking about 10 minutes or so. But that's because this particular type of problem I don't know if I would say struggle with. It's just that I always do not recognize it because it's such a crappy problem, if you ask me, because there's nothing algorithmic about it, especially for a problem this difficulty level. So I'm looking for my pen so I could draw. But yeah, it's not that interesting at all as a result. But yeah, the idea for this problem though, it is just dynamic programming, right? And there's nothing that crazy about it. In a naive way, you can, and this is why my quote unquote my beef with it is that this is a dynamic programming, and this is a very what's it called? Very standard what's it called? Target sum problem, right? It's a pseudo polynomial. It's a very well studied pseudo polynomial NP complete problem, right? Is pseudo polynomial. I mean, is it NP complete or just NP? Actually, I don't remember, but at least NP, right? It doesn't matter. I mean, I'm pretty bad at about it. I'm not a big researcher, and for me, NP is the same as NP complete because it is for at least in the terms of what I'm trying to accomplish, which is competitive programming, which is of course both of them are essentially intractable to do. You know, for big ends, right? But the part that is relevant is that it is pseudo polynomial, meaning that you could do a DP on the bit widths or the word widths or whatever. And this one, the biggest number is 4,000, and k is equal to 4,000, right? Or at most 4,000. So that's kind of the target, k being the target, right? And that's basically it, right? And with the with the dynamic programming, it is pretty straightforward. You just have an array. You could imagine it being true for 0 because you can always have 0 elements, and then just start with force, right? And then you could say, okay, maybe the next element is 2. Then what happens? Well, you just kind of redraw it. Well, this is going to copy, and then this reuse it. Then it's going to go here, right? Right? And then maybe you have a 1 or whatever, right? Then now these two copy, but then these two also go one to the right, right? So then you have something like this, right? And that means that yeah, you can hit 0, you can hit 1, you could hit 2, you could hit 3, but not anything bigger. And that's kind of the idea. I mean, I know that I'm going really fast, and honestly, this is pseudo polynomial. Like I said, I think it's target sum, maybe 0. I mean, 0 sum or something like that. You can definitely read up on it. It is in most algo class as a beginner dynamic programming problem type thing. So the thing about this problem, and this is why I don't like it, is that it's just based on this, but you have to know this one trick that if you haven't seen it before, you'll never get it. Maybe not never, but just like way, you know, it's just, if you haven't seen it, it's hard to come up with, and if you've seen it, it is just dumb because it doesn't take any skill, if you will. Which is that, notice that I write everything in true force. Well, what is true force equivalent to? Well, that is just you go to bits, right? So you could have one. How does that keep on happening? 1 0 0 0 0 0 0, right? And then now you can say, well, you can say that for each bit that was in the previous thing, you either do nothing, right? Or you shift it by 2 because whatever it used to be is just going to, and then you take the OR of it, right? So that's kind of the idea. I mean, that's not kind of the idea. That is exactly the idea, which makes it very uninteresting because if you've done it once and you kind of just know about it. And it's something that I didn't do as a kid, if you will. So it always takes me, and for me, it just, like, it always baffles me that Leetcode does it. So because it's just such a useless thing to do. Like it doesn't have any skill, so it's just not interesting. So I always get surprised because I'm always trying to find like an actual algorithmic thing to solve, but it is what it is. It's just my rant. You don't have to agree with it. But yeah, but basically you have basically the original this thing, right? You have the original. Let me change the color real quick. You have the original this thing plus this thing, which is the original thing shifted by 2 because of this 2, right? And then you do a bitwise, and yeah, if you store them as a binary number, then it's just a bitwise OR, and that's it. That's it. That's it. That's it. And we'll go over it in code, obviously, but I wish I don't know what I dropped, but I wish I can explain a little bit more. But really, there's, like I said, it is uninteresting for that reason. And yeah, and this is like literally this is my code. I have this so that I could test the worst case. I thought maybe I could use this. It's fine that we don't. But yeah, so n for every number. We'll go over this in a second. But here we just have the answer set up for I, which is the target, right, or whatever in the description, right? Or for the cap, sorry. Right, the cap is equal to I. We go, okay, well, set current is equal to 1. Remember, we call that 1 in binary just, 0, 0, 0, 0, 1. So that in that sense, this 1, it is on the 0th bit, right? And if you think of it dp, then f of 0 is equal to 1 is what this is saying, right? And then for each number, we have current. So current is just the thing that we showed, right? We just shifted downwards, nothing changes. And then, sorry, this one, I messed it up. So current, nothing changes, it just shifts down, right? And then you have the OR function, right? Meaning that we take the original thing and then we add to it this part. And we shift it by either X or I, the mid of it, because this is the cap, right? So you shift it by the cap, and then this OR function will give it to you in a binary kind of way what the answer is. I added a shortcut, which is if we found K, we don't need any more numbers, just break, because then now we could set it equal to true. And then after that, if it's not true, then we do this thing which is related to this. And T is just basically K1s or something. Either K1s or K plus 1 1s, but it doesn't matter. The idea behind it is that if you kind of do this shift, a lot of these shifts, you're going to get a really big number, right? So for example, this is, I don't know when they changed this, but this is T, right? But let's say you do a lot of shifts, you have a lot of numbers, and then now you have some, well, there's no 2's in binary yet, right? So something like this. The idea behind here is that, behind this code, is that we just chop these off, right? Because everything, it implies that everything before this is 0, and then it chops these off so that we don't have to do computation on them or calculation on them later, right? So that's basically all this bitmask does. Is that you give it all once, you chop off everything before it, so then it, like, instead of having a 50-digit number, you may keep everything in like a 20-digit number, so then you chop it off. And it gets really big really fast, so you have to do it. And it's just an easy thing to do. You could watch me live doing it. I mean, it's not that bad. Yeah, and that's it. And then if it all goes well, then yeah, then there's a bit in the kth bit. This returns true. We are happy, and we are Gucci, right? This is going to be of n times n times time this shift thing, which is always sketchy, but apparently it's very fast. My code takes 13 seconds to run on Leetcode. I don't know what to tell you. Like I said, I'm not a fan of these. I kind of YOLO'd as well when I submitted. I wasn't sure that was going to pass. If I needed to do one more crazy thing, and with Leetcode, you never know. So yeah, but yeah, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve it live in the contest. Thanks. Wow, Larry, what is wrong with you? This is what happens when you don't read the poem. For some reason, I thought it was 3. I got it stuck in my head. Because it was easy and I watched it. Okay, let's go, Larry. Dummy. I'm lucky it doesn't count. Oh, jeez. Can you read the problem first? Okay. Alright. Silly mistake. Alright, nums of size n and a positive integer k. Okay. Cap. It's not really a cap. It's a min. It's a 4, not a cap. But okay. Oh, excuse me. Jeez. X. Okay, so we want to replace what's k? Oh, the sum is exactly k. Oh, we have to try for all of them. Okay. I mean, it's just counting, right? Oh, it's subsequence, not subsequence. What are the numbers? 4,000. So we try for 1. 1 is just everything, right? So oh, maybe I must. No, it's min. Oh no, this cap is such a weird word. No, I misread this. This is min, not 4. So okay. So that means that if cap is 1, then every right issue is in the thing, right? So that's different. Okay. Is it just do? So and then we. Huh. I mean, it's still like a collection, right? But when we do it backwards, I think that's probably the key. But 4,000 cube would be too slow, right? So I have to do a little bit better. It's not a bit mask thing, is it? So I'm just trying to think how to convert this to this easily. I mean, in a frequency table, it's straightforward, but in terms of the DP, so we don't have to do more work. Because then you have to write it again, right? So I don't know. Is it easier to do the other way? I don't think so. Am I misunderstanding this form? So it is a cap. I was wrong, by the way. But how would I do this? I guess it is probably bit mask. I thought maybe we could be a little bit better, but maybe I'm wrong. Yeah, and it's just 4,000 bit mask, which is I don't know. Okay, we'll give it a YOLO try, but honestly not sure. I do this in a smarter way if we combine them. I don't know. So then is it K? No, it's N. What's N? N is the number of numbers. What is N? Of size N, so it's just okay, number of numbers. So everything equals to 1 is always true, I suppose, but do I even need to make this optimization with the counters? I don't know. Maybe I don't. I'm a YOLO. I honestly don't know. For X and nums, let's do have a what am I writing? I'm a little bit rusty for some reason. So then we have this min and yeah, right, something like that, and then answer sub I is equal to 1 to the k, right? Maybe we can chop it off a little bit, but yeah, I think this is good. We can actually even terminate early actually. Did I not call fmin? This assignment out of scope, what does that mean? Oh, I is out of range. What? Oh, it's not K, it's N. Why do I have K here? Alright, I mean, this is not a question. I guess it's just whether it is fast enough. We can write, you go to 4,000 times 4,000 and then we'll see. Right, and maybe it's too slow. Then we have to do something smarter. It is very slow actually. I mean, I know that we did it 3 times. But okay, if you time out, just time out already. Come on. Okay. Does it even get one of them? No? Don't think so. 4,000, 4,000. I mean, this should be. What is it? Okay. Is it +1 maybe? I don't know if this is off by 1 or not. But is that faster? Okay, I mean, it is much faster. Is it fast enough? I don't know. YOLO. I mean, I wouldn't be surprised if it times out, honestly, so And in that case, it is what it is. But it's a medium. What am I missing? Am I missing something silly? Huh, no, I guess not. I spent too much time on that one because I thought it would be something crazier. Thanks for watching, everybody. Hit the like button and subscribe button. Join me in Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to get to good mental health. I'll see y'all later and take care. Bye-bye.